Part 6, Applications of Quadratic Functions. The height h in feet of a model rocket above the ground t seconds after liftoff is given by the function h of t equals negative 5t squared plus 100t, where t is greater than or equal to 0. So we're starting with t equals 0. That means times 0 when the rocket first leaves the ground. We want to know, when does the rocket reach its maximum height, and what is that maximum height? So let's figure that out. We know that if we graph this, we're starting just where t is 0. The rocket's going to go up, and then eventually it'll come back down and hit the ground. This is how gravity works. We want to find this maximum height right here. So to do that, we need to find the vertex. So our t coordinate, or our time, would be negative b over 2a. In this case, our a is negative 5, and our b is 100. So the t coordinate in this case of our vertex is negative 100 over 2 times negative 5, which is 100 over 10, or 10. So after 10 seconds, we've reached the maximum height. So what is that maximum height? Well, to find that, we need to substitute 10 in for t, so we need to find h of 10. So we have negative 5 times 10 squared plus 100 times 10, which is negative 500 plus 1,000, or 500. So after 10 seconds, the rocket is 500 feet above the ground, and then it turns around and comes back down. So when does the rocket return to the ground? What is the time at this point right here where the rockets return to the ground? So that's an x-intercept. In this case, a t-intercept, because that's our t-axis. So let's find that. We need to find the t-intercept. So we want to know, when does 5t squared plus 100t equal 0? So when is the height equal to 0? To find that, I'm going to factor. I can factor out a negative 5t, and I have a t minus 20. So either negative 5t equals 0, or t equals 0, and that's this point at the beginning, or t minus 20 equals 0, which means t equals 20. So the rocket is back on the ground 20 seconds after takeoff, which makes sense, because if the rocket was at its highest point at 10 seconds and a parabola is symmetric, then it will be back on the ground after 20 seconds if it started on the ground at 10 seconds. Let's try one more application. Theo has 32 feet of invisible fencing to create a safe space for Max, his Irish wolfhound. If Theo puts this safe space in his backyard, using the back of his house for one side of a rectangular area, so there's the house, and this is his safe space right here. We're using the back of the house as one side of the rectangle. Then what's the maximum area of Max's safe space? So let's call this side x and this side y. So we have 2 x's and 1 y. They all together need to be 32 feet. That's how much fencing he has. So those 2 x's and the 1 y, those 3 sides, need to be 32 feet long. We also know the area of a rectangle is the length times width. So in this case is x times y. And this is what we need to maximize. We want to maximize the area. So let's write that as an equation in only one variable. If I take this first equation that I wrote and I solve for y, I get y equals 32 minus 2x. And I can substitute that in for this y in the area formula. So the area in terms of x is x times 32 minus 2x, which we could write as 32x minus 2x squared. And if you like to have the x squared term written first, you could write it as negative 2x squared plus 32x. So this is the parabola that we need to find the vertex of. We need to maximize the area, which is going to be the vertex. So we need to find negative b over 2a, which is negative 32 over 2 times negative 2, or 32 over 4. We have negative over negative makes a positive. We have 8. And that's what x is. So x would be 8. Those 2 sides of the rectangle are 8. What's the other side? Well, if x is 8, we know that y is 32 minus 2x. So 32 minus 2 times 8, or 32 minus 16, or 16. So this side is 16. Now, what does the question ask? It says, what is the maximum area? So what's the area? Well, that's just length times width. So the area is 16 times 8, or 128 square feet.